Okay, good morning, everyone. We can start. Thank you very much for attending today's session. I would like to thank first and foremost our startups for sending their PPTs not after we started the presentations. But in any case, we managed to get them all in one place, so that's success already. So I will not talk a lot since we could spend that time for you to present your ideas. Just a few guidelines. As we've told you, this is a competition. We want to see your war face or whatever that is called. Okay. You have 4 minutes strictly. When I say strictly, you will get a notification from me, physical one, something like this, okay? But you have 1 minute left, and if you go more than 10 seconds after 4 minutes, we will have to skip your slides, okay? Because we all have to respect the time of the others, the time that the other teams will keep, and we want to keep it fair. Now, talking about fairness, at the end of the presentations, you will be all able to vote for the 3 most innovative or impactful or, I don't know, sexy for you startups you have in place. So we believe that even if this one vote is yourself, at least with the other 2, we can get a winner. Actually, I don't know whether this is one of the myths that were built up later on, but during the Persian Wars, the Athenian generals voted among each other who was the best general. So we had 2 votes. They voted for the best one and the second best one. The second best one was Miltiades after the vote. Okay, the first one was no one because everyone voted for themselves. So don't do this. We want to get the first place, not only the second place. You will get a QR code at the end on the screen. Just use your phone. It's just a multi-box. Select the 3 top for you and just provide 1 line, 2 lines of feedback from one of the startups, whatever that is, so that we can aggregate some useful content for everyone. That's all from my side. We have also a representative from ESA today with us. Most of you, I think, have seen him today. Do you want to say a couple of words? Yes. Yes, please.
Less than 4 minutes. And you'll wave at me with 3, okay. Hi, so I'm Nick Appleyard. I look after the Access program in ESA, which is the commercialization building businesses, which includes the ESA BIC. So I like these days. This is great. I get to hear everybody's ideas. 10 years from now, we come back to the Greek Space Tech Forum 2036. The leaders of the Greek space industry is going to be the people who are in this room today. I don't know which ones, but whoever it is, they're here today. So I'm looking forward to coming back for that. As a startup CEO, though, one of the most important things you have to be able to do is to explain in 3 to 4 minutes, what is your company? You're explaining this to a customer why they want to be your customer, to an investor why they want to be your investor, and you have to be quick because you may only have their attention for 3 minutes. So go.
Do you want to come back for the photo?
Not so quick.
Okay, then we can start. We will not be introducing each and every speaker. You are 20 teams. Whenever you see your logo, you know it's you. Okay, so you run here. The time is counting. 3 minutes and 50 seconds. No? Okay, thank you.
Okay, thank you. So hello, my name is Nicolas Zobakis. I'm CEO founder of Trim Signal. Trim Signal is a semiconductor company with a technology that will be applied in special application like Doppler LiDAR. So the point here is we have a technology that we can improve the operation speed and the performance of any dedicated signal processing unit. And the point here in LiDAR is that, except that we increase the performance, we also support the real-time computation of this application. So all of this is that we have the ability to see, to scan the sky and to take feedback about an analysis of the wind. What we really did is to trace the particles of the wind and to measure the speed, analyze the Doppler effect. This give us the ability to trace any object from particles to clouds. You see here that here we have traced clouds. I don't know if you can see the cursor. So the point is that we can detect any object, any kind of objects, from very small objects like particles to any flight drone or etc. So this is also have an interest of dual use applications. So the point is that we have the emission signal, that is the laser. We have a feedback from a reflection of this laser from particles. To analyze the Doppler, we have an FPGA processing unit that we process all these signals and give the user the ability to scan a very wide area. So this is a family product that we intend to produce at the next month. In reality, this is the same family of the product that any individual product support different kind of range and resolution for specific applications. In the context of the ESA BIC program, we focus mainly on the wind lidars. So the interest here is that the wind power is in high interest to increase for the production of power, of electrical power. So it is an industry that we focus and we have a close collaboration. Also, we want to have collaboration with space agencies, with environmental entities, and also dual use application and companies that are active in this area. Thank you. This is my...
3 minutes and 15 seconds. The one with the lowest score gets an extra bonus. Okay. The next one is from Cloud Signals, but they are not yet here, so minus some points. Same with Loxio, I think. Oh, no. Sorry, Nikos. Sorry. So next one.
Thank you, Orfea. Good morning, everyone. My name is Nikos Kanistas, and I'm the general manager of Loktio. Loktio is a Greek SME established 7 years ago, headquartered in Athens, Greece, and having R&D activities in Patras and Barcelona, and also a business development presence in Japan. The founding team is consisted of engineers with strong expertise from both industry and academia, and we invest over these years in strong partnerships with leading organizations from both industry and academia, and we focus on academia because we want to innovate. We develop position technologies for advanced challenging operating environments, and we'll also demonstrate our technologies because we want to have maturity on our developed technologies, and also the demonstrators that we build help us to assess the performance in real world environments. Positioning requires nowadays precision low power and resilience. However, this is not, it is quite challenging to address all three of them because traditional GNSS satellite-based systems degrade significantly in challenging environments. Moreover, the positioning is a power-hungry processing, and battery-operated devices cannot afford the processing effort required. And moreover, modern applications, positioning systems in modern applications are exposed to significant jamming and spoofing and other attacks. So resilience is also quite challenging. So we have started from developing a low power positioning, enabling an narrowband diode chipset from a Chinese company, Goodix, enabling position to this chipset. We managed this 4 years ago. In the meantime, we were looking for alternative position technologies, and 5G is one that seems to be the most promising one. We managed to demonstrate advanced positioning technologies through 2024 and 2025, and we moved on with adding security features to our technologies in order to provide resilient positioning. So we delivered early this year an open source simulator, Verilog, and there is an ongoing activity on 5G LEO PNT because 5G is moving to space. Also, we have seen hybrid solutions combining GNSS and 5G position technologies. And here I want to highlight the contribution of ESA because these activities would not be feasible without the help from ESA. But developing technologies is not our target. Our target is the market, so we're looking for partnerships with industrial partners in order to co-develop our technologies to provide services and products and accelerate the transfer to the market. Pilot deployments is also something that we're looking for to gain maturity and demonstrate our business value to end users. Thank you very much.
Thank you very much. We now do have a representative from Cloud Signals, so we can go back and go on with it, please. Sorry, Paolo.
Hello, everyone. My name is Alex Nielsen. I am a research engineer from Cloud Signals. And today I'm going to be presenting to you one of our products, a private 5G network, with or without a backhaul. So first of all, we are a fairly small team. We mainly operate in the SATCOM space and the 5G network space. We mainly focus on end-to-end deliveries, and we usually take ESA-related projects in R&D. So the reason why we're presenting this product is because Wi-Fi seems to be quite outdated in private resilient solutions. There is no service identity, there is very poor coverage due to the way that those spaces are being manufactured. So usually we're referring for maritime vessels, we're referring to remote areas for agriculture, places where the need for a network is like very high, but then again, Wi-Fi does seem to fall short in terms of security, sovereignty, and also resilience, as I mentioned earlier. We're also looking for per-device policy, remote control, issues that do scale, however, Wi-Fi is not really built for them. What our system offers is one or more 5G cores, the process of orchestrating or using standalone networks for 5G, with a management agent. So essentially, if you think about it, it's one or more private 5G networks that we ourselves set up. And then we also allow for a layer of abstraction for what we call fleet manager to be able to control all of these networks. Essentially, in our main scenario, which is the maritime one, you could expect each vessel having its own private 5G network with its very own core, and then the fleet manager being the headquarters, being able to manage the subscribers of each vessel separately, being able to apply policies, and obviously role-based access control. Obviously, there is a lot of 5G in this conference as well, and we have started to notice the shift away from Wi-Fi and into 5G. We can see that so many sectors can benefit. Our main verticals are maritime, security and defense, agriculture, and the industrial sector. And of course, 5G is a sector that keeps on growing, and I do believe that 6G will come and tie the whole thing around. And we're going to be able, obviously, to keep growing, keep making products that become more and more resilient, and also more customizable for each use case scenario. So our solution, we've noticed, checks every box for the cases that I mentioned previously. The most basic satellite and Wi-Fi solution that most carriers go for is very much lacking in the coverage sector. That's why we also have backhauling satellite solutions. It obviously has no per-device identity policy. It barely operates offline, whereas our solution, while having the cores themselves on the vessels on site, let's say, we are able to maintain the policy. We are able to keep the network running even without having internet on the backhaul. Obviously, there's no fleet orchestration, and there's also no ownership or control. Connectivity, you own and can control. Thank you very much.
Thank you very much. Now we can stop bowling circuits integrated and get Paolo on the floor. Sorry about this. So you get 10 extra seconds.
I was asking. So I switch with the key.
Yes.
Okay, good morning, everybody. I'm Paolo Fioravanti, CEO and co-founder of Circuits Integrated. What you see here is our flagship product, a rendering of it. It's called Kytrion, and it has already achieved a few acknowledgements in the market since launch last year. Basically, it's a module, a platform for flat-faced array antennas, which are antennas can transmit and receive in specific direction without the need of any moving part. These kind of antenna are currently represented about 50% of the market. Their growth and success started with the Starlink, and is following a new the new space age hockey stick development. In this sector, in SATCOM, and for flat-faced antenna, there is a bottleneck ahead, which is silicon, access to silicon, production of silicon, and governments are trying to create new fabs. Elon Musk himself, which is buying currently about 5 million chips a day from ST Microelectronics, is building his own fabs. So, and there are just a few suppliers of chips needed in this system. So there is a clear bottleneck ahead. with volumes of devices expected in 2033 to reach the billions, tens of billions. At Circuits Integrated, we cannot open a new fab, but we can optimize how silicon is used, reduce the size of this antenna, reduce twofold the use of silicon, and provide the same performance with enhancement in swap, size, weight, cost, and power needed. This enables to feed into the existing SATCOM market, but also to support the development of the new ones. And our go-to-market strategy initially focused exactly on this, especially in delivering to CubeSat and defense application. How we do this? Heterogeneous antenna and package integration. We stack in 3D the antenna, silicon chip for the control, and compound semiconductor electronics that provide more power and better noise performance. Chytrion will enable, for the first time, compound semiconductor to be integrated in a flat format and a small size factor. We have 5 patents around it, and we believe we can penetrate the market and keep some advantage with respect to competitors, at least initially. Just to make all visual, on the left you see an Amazon Leo antenna just released a month ago, 20 by 20 centimeter more or less. On the right, how small it could be if it was to incorporate our chips. Not just smaller, less weight, but also 10 times faster because of the architectural change and the basic innovation that we introduce. This is a very ambitious plan, a plan that needs a very strong team to be executed, but this is exactly what we've been doing for 8 years now at Circuits Integrated, delivering to third parties systems of similar or higher complexity. Today, we are doing for ourselves, for Chytrion. The market is huge, it's growing very fast. Just assessing Earth observation and defense, without counting the ground segment, there is an expected 11 billion market just for flat panel arrays antenna by 2033. Any company achieving more than 10% in this new growing market would be a decacorn. We expect to be less successful than that, but with the ambition to be there in the future. We already have traction. We have a pipeline of about 40 million ahead. We are starting to execute on chip deliveries for a customer in wireless power transfer. And we are ready to make this a reality, but we still need capital injection. We quantified our need at about 6.5 million. This will enable us to go to a demonstrator by end of 27 and achieve a product grade deployment of 2028. Today we have a small syndicate in place with a lead investor and a round table with about 3 million worth possible investment. We are looking for more and looking for the next investor. So the request here is if somebody wants to step up and provide this missing 3 million, it would be great. Thank you. Thank you for listening.
Thank you very much, Paolo. We move on then with Solid Cosmos.
So, hi, I am Dimitris, the CEO of Solid Cosmos. As you know, radiation affects onboard computing systems. Radiation can make systems in space fail. So our team makes products and services to reduce this risk. So we are a spin-off from the University of Piraeus, the first spin-off. We have built the company. We are 3 founders. All of us have decades of experience in building fault-tolerant systems. We have built ourselves computing systems for space, and we know what radiation can cause to this hardware, and we know how to protect it. So when you design a system, you need to analyze it, protect it, and prove that it will operate in radiation. This is what we do. So you find the weak spots in your design that can fail due to radiation. Then you insert in your design fault-tolerant techniques in order to protect it. And then you need to perform different kind of tests, like radiation testing, in order to validate and verify that it will operate in space, in orbit. So what's the problem that we solve? In space, as we said, radiation may flip some bits in integrated circuits. These bit flips can make a satellite fail. So the usual way to test a system before you send it in orbit is to book at a radiation facility some beam time, pay around 8,000 euros per hour to perform these radiation tests, wait around 6 to 12 months for your beam slot, and then take your whole team and go in space. Go in the beam facility to perform the radiation tests. And the problem here is that you can find problems in your design when it's too late, when the design is almost frozen. This costs a lot in companies, and our solution tries to solve this problem. So what is our solution? SKRaft. SKRaft is an electronic design automation tool that actually causes, by purpose, faults like radiation causes in hardware, in real hardware, that is prototyped in FPGAs. In your lab, in minutes, you can test your design every day in your lab. You don't need to book for a beam slot. You don't need to trip abroad. You just prepare your design before going for the beam. This means that you need fewer expensive beam hours. You find the weaknesses on your design, you correct them, and then you go to the beam to confirm that it operates, not to debug. That costs. So one campaign, well prepared. We have proven our design in real. Okay. Okay. In real use, analyze RISC-V applications, AI accelerators, and have used our tool in neutral radiations for fault monitoring. And we provide this solution in a fraction of what other companies give for similar solutions. We provide this with 1.5 to 7,000 euros annual subscription rather than the tens of thousands of euros per year. So we have achieved until now, we are the first spin-off of the University of Piraeus. We have just received a fund from Coralia Ventures to accelerate our go-to-market path. And we have used SKRaft in many pilot tests for real designs. Our SKRaft works, it's real, and you can use it. So what we are looking for, the Greek government just said that they will invest 350 million euros to make their own satellite fleet. As a company, Solid Cosmos can provide services and products to reduce the risk of radiation making their designs vulnerable before they send it in orbit. And we are also searching for angel to invest in this seed round with the same terms as Coralia. Thank you.
Thank you very much. Just a reminder to the teams to try to speed up from the very beginning. So we move on with Ioannis Maximidis from Stellar Phronesis.
Thank you. It would be nice to talk after Paolo's talk, but okay. With small break, we will continue Paolo's talk, and I will tell you about antennas and antennas for space, but let's first begin with some quite recent news. So there was one outreach of Starlink connection to drones when a lot of drones were in the same place, so Starlink stopped work. And so this actually shows that there is a limitation on maximum user per satellite, and also on the threshold on how many users can be on the same spot. So how do you solve it? You can solve it actually increasing antenna dimension. You need to increase the antenna in order to have smaller beams looking to the ground, and also you need to use so-called multi-beam. So you need to send simultaneously in multiple directions. And these two things actually can solve this bottleneck. So the dimension actually is also confirmed by various players trying to make these huge antennas that you see below, and also Musk confirming that he is very happy that he is on LEO and the size of antenna can be small. So what we do, we are developing actually photonic chip that can reduce the mass of the system. You see an example of an analog beamformer which generates some number of beams. This is a feeder for a reflector. And on the left, you see the similar thing that is in photonics. And you see how small can be the size. So here actually, just to explain where we put it. So before you have your antennas and amplifiers, you still need them. Then you have our photonic core, which we're also developing some clever algorithm to control it because it's an analog system at the end. And then you have the digital processing to process the data. So we are on the photonic core and on the control of the system. If you compare to, sorry, Paolo, I didn't put you next time. If you compare to the others, so in analog, you have the swap issue. It's very difficult to have multiple beams. You need actually multiple system for it. If you go to digital, some problems are solved, but if you go to higher frequencies and you want to have higher bandwidth instantaneous, you still have a problem. And then there are photonics. There are all cost companies working on photonics, but they have two issues. One is the reconfigurability because the system becomes large and it's difficult to control. And the second one is actually the scalability because you need to combine multiple of these chips, and this is what actually we are doing. Who we are? We are two founders, me, Ioannis Maximidis, and Christos. I have experience in antenna designs for 5 years during my PhD with project with the European Space Agency and postdoc in photonics for another 5 years. So know this field quite well. And Christos has actually background in mathematics and more business oriented. And he is our mind behind the control and trying to commercialize it. Currently, we are looking for small amount to build our first prototype where we can show what we are promising, because up to now it's university chips, which are not as advanced as we need to be. Okay, the traction is, we are in ESA BIC. We are actually now currently signing some NDAs with Airbus for joint projects. And just to conclude, I just want to mention that photonic technology is not just sexy technology. This is something that already happens because NVIDIA actually put 4 billion in photonics. You see a lot of startups with 5-10 millions around Europe trying to build some companies for photonics. So photonics is happening, and we need to be there as Greece as well. Thank you.
Thank you very much, Stellar Phronesis, and we move on with QRBit.
Good morning, everyone. My name is Aristathis. I am the CTO and one of the co-founders of QRBit. QRBit is a deep tech spin-off from the National Technical University of Athens and the Institute of Computer and Communication Systems, built from years of research in the field of optical and quantum communications. Our team spans expertise from software engineering to optical and quantum communications, as well as space communication engineering. At QRBit, we believe the future of space communications will be optical and quantum as well. That's why we're trying to build key enabling technologies that will enable this new generation of space missions, combining software, hardware, as well as real experience from demonstrations. We're developing these new technologies. So, in QRBit, we develop a full cycle of, we support a full cycle of developments beginning from design. We are making mission planning softwares, which makes the life of engineers easier because they allow them to assess the feasibility of such optical and quantum links. We build the critical hardware needed for such missions, and then from real missions, and by integrating these products into real missions, we are taking the feedback and putting it back into our products. So our motivations, as many of you know, the space industry is in a turning point. As satellite constellations grow, the amount of data generated from them is enormous. So traditional RF communications are being pushed to their operational limits, and this is where optical communications comes into place, along with quantum communications, which will represent the next generation of secure global networks. This shift is creating new opportunities for new products and new infrastructures. What we have achieved till now, although QRBit has been founded last year, we have managed to turn our research from laboratory into some operational space technologies. Starting from the software, we are developing the Quanting, as we call it, through our ESA BIC Greece incubator contract, which is a mission planning software currently sitting at TRL 5 and 6. It has been validated using real mission data that we performed, and it is expected to be launched in the market in a few months, hopefully with a few customers. We're also developing free space optical terminals, FACOs as we call them, which are double use and can accommodate both optical and quantum communications. And we're also are actively participating in international campaigns with collaborators like ESA and JAXA, as well as in Greece with a lot of demonstrations in the Helmos Observatory. So QRBit has built a very good technological foundational basis, and we have proven that we can deliver what we are saying. So we are looking for partners to take to collaborate in future missions, and as well as pilot missions to deploy our technologies, and of course investors who share the same vision with us and want to shape the future of optical and quantum communication. Thank you very much.
Many thanks for your presentation, QRBit, and we move on with Illicens.
Good morning. I am Thanasis. I am co-founder and CEO of Illicens. We are a materials informatics company, and we develop a system that makes curing of composite materials faster and with less energy required. Probably if you go to the booth with the exhibitors, you can see that some of them are dealing and manufacturing composite panels. That's a basic structural element of all the satellites. Currently, the method of manufacturing is something called autoclave. It's a big oven, basically, with vacuum. And the companies use recipes, curing cycles that know and trust. In cooperation with material developers, sometimes also with trial and error. And with our system, using IR and also Edge AI, we reduce by 30 to 40% the curing time and 40 to 60% the required energy. This for an SME, which is a quite important part of the European manufacturing ecosystem, means that we save every year a significant amount of energy, plus reduction of emissions and less material scrap, because the curing cycle is optimized. So with some quick and dirty calculations for a typical panel, we save around 20 euros per square meter. How the system works, we have the usual composite material preparation with the layup. The material is loaded in an IR chamber. We already have a pre-trained surrogate model, which is physics-informed. It predicts cure state and also predicts hotspots and other possible defects during curing. And the Edge AI controls and adapts the curing cycle, not for a worst-case recipe, but in a curing cycle that will reduce time and energy. The user can optimize or can select the curing cycle. We have the sensor feedback, mostly using temperature sensors in a closed loop. And we have a fully traceable process of manufacturing. This means shorter curing cycles with higher throughput, because we can produce more parts in the same amount of time, lower energy. And we have a digital record that usually is required for certification and qualification purposes. In Illicens, we develop also other solutions with structural health monitoring. We develop our own software and hardware. We also have an installation in civil infrastructure. We are a material informatics company. This means that we help reduce physical test campaigns with validated models that we can predict the behavior with a good amount of accuracy in seconds. And we have developed also a platform to help companies that develop materials to perform material screening for safe and sustainable design guidelines. So why we are different? We produce our own hardware and software stack. We use physics-informed models. We offer closed-loop control, so it means that the data of your manufacturing process are yours and only yours. And we offer full digital traceability for certification. Our traction, we have Horizon Europe, that is basically development of the infrared curing system. We are very happy to announce that we got the ESA Pre-Accelerator project. We are one of the 6 Greek companies. We also work in Bio3D Green, which we developed the SSBD framework for graphene foams. Of course, anything would not be possible without the support, initial support of ESA BIC Greece. And we also, our SHM decision support system is a contract for an EDF program. We also have some feedback from possible customers with material and structure manufacturers and material developers. Whether if you vote us or not, we will be very happy to discuss with you. Or if you visit Patras, we'll be very happy to meet and discuss. Time? More than 4.
Minus points. But with that last comment of getting people to vote you, I think next year we should have a Eurovision system or something like this. Keep it more interesting. Anyways, our 12 points to no, okay. Now we have Odes. Our Odes or Odes is your youngest brother, sister, whatever. They are the 32nd startup that joined the BIC after we had the limit, so that was a close one. But but in any case, we would be having an extension of the program, so there will be more people to see next year too.
Good morning all, we're Odes. And what we're doing is that we fight every day to reduce the failures of the microsatellites and CubeSats, so the new mission, the new space. What we have is that in researches, we have seen that more than 4 out of 10 CubeSat or microsatellites have failed to meet the full operation of their requirements. So this causes an impact, an economic impact, a high economic impact, but also an environmental impact. All these missions that are failed are becoming space debris. Space debris are full. So what we're trying to do is to be proactive. By being proactive, we don't save the space debris when we have them in orbit, but we're trying to validate our missions on ground. So we have bring all the know-how and the knowledge from institutional space, from traditional space, and we have built the holistic platform of simulators. We follow the mission from phase 0, from proposal phases, from design phase until the end of life of mission, entry orbit. Our customers are mainly all new space companies, and the key point for us is the academia, because in academia we have the future engineers, and the future engineers will want to be attractive with our tools, and when they are outside of the world and become a full-time jobs, we want to have Odes to have the simulators. All these simulators have been built based on real missions and have been already validated in orbit, and it is something that is not offering nowadays in the industry. And not only in new space, but also in institutional space, we don't have a holistic platform that offers all these in a holistic platform. So you have to go from a vendor to another, and you don't have the interfaces to easily simulate and validate your mission. Today, we have 3 simulators and 3 tools in this holistic environment that helps the mission designers and the new space industry to validate their mission. We have Vela, which is the system budgeting. We validate from the beginning of the mission all the systems, the ADCS, the EPS, the power, and the radio frequency. We have Harmonia, which is Argus, to be honest, the name. It's an RF interferences analysis tool that, because we have a very crowded system up there with a lot of satellites, we have a lot of interferences based on RF, especially if you're using UHF and S-band. So we have an automated system that resolve all these interferences. And we have Pythia, which is the operation simulator, which is used for rehearsals and command the satellite before real execution of the commands. So the subsystem simulator, we save also a satellite before 2 months. We reproduce the issue and we run thousands of simulators in order to find the correct configuration. We send the configuration to the satellite, and the satellite now is stabilized and saved in orbit. This Pythia, the operation simulator that you can have rehearsals before real in orbit, and the Argus, which is the interferences analysis tool. And okay, all this was the romantic part, the technology and all this stuff, but now we're doing business and we need values and numbers to prove that we have a sustainable product. So the market is exploding, is one of the most exploding markets nowadays for the industries. More than 8 billions have been invested in new space, and every year we see more and more launches and microsatellite satellites. I am Giorgos Kalanos, I'm the CEO and co-founder of Odes, and together we have Orfeas and Romanos, and of course we're a spin-off company of Femtech Space that provide us the IP and business and technical advices. Thank you.
Thank you very much. And now we can move on with space mobility.
Hello all. I'm Konstantinos co-founder of Space Mobility. What we do is we bring advanced mobility for the era of physical AI. Recently we heard about humanoid robots in China breaking the human record of semi-marathon. But what we did not hear about was how many times the robots stopped, the batteries were swapped, and the robots were cooled by the team members. So we understand that better design and controls are necessary for the next era. Sorry for that. The future, for sure, is robotic. We all know this. So what is the main question here, at least for us? The energy consumed by these robots. So the main question is which robot is best for its job, for its mission? This is an extremely mathematically and technically strong question to answer. And this brings us to who we are. We are a team of 3 co-founders that work on this kind of problems for more than 15 years. In 2024, we founded Space Mobility, and our achievements so far include completion of the ESA BIC accelerator, secured 400k euro equity-free funding, completeness of 3 pilots across Europe in future clients, and pending decisions for at the moment for up to 2 million euros. We build the full mobility loop. So our product series includes the Leo family, mobile robots, quadrupeds, wheeled and hybrid, and also the Ioannis Drive series that power our robots, and also the perception stack, which includes Perceive and Regulus. Here's an example of our robot Leo W1, especially designed for requirements coming from our future clients, let's say. And here they are performing in real environments. Let's a little bit talk about our target markets. This is important. Maybe I will skip some slides later, but this is important. In the era of AI, this is the self-reinforcement loop that matters. More AI needs more materials, more energy, and more infrastructure to turn these materials and energy into useful stuff, and many, many robots performing on Earth and also in space. So we have begun to penetrate penetrating all these markets up until now, and we are very happy for this because the numbers are huge. Our primary market, the beachhead, includes PV parks, operation in PV parks, mine inspection, curtain walls, infrastructure, and space, all under one technology family that we are building. Here we will see some inspections taking place in Spain, which are continuing doing so. Anomalies being defined that were the requirements from our client, like water beds. This is about our business model, but this is not important right now. And we are very happy for the future because we have scheduled a Luna campaign on September with DLR, and also PV pilots in Spain, mine pilots in Greece, and construction pilots in Stuttgart and Spain. And we are very happy for this. So the future is robotic for sure. Stay tuned, and thank you very much for your attention. I will be happy to talk with you.
Thank you very much. I also wish you win the next Robot Olympics too. Yeah. So we move on with stellar discoveries.
Hello to all of you. We are Stellar Discoveries. We are a company which is about 1.5 years old under ESA BIC incubation in Greece. And we merged actually two different topics, biochemistry and planetary sciences and geology, to solve a problem. We want to be an interplanetary species, okay, but we don't think about what we will find there. For example, the Artemis missions that are in the next 7 years, and they take us to the moon and they want us to stay there, they don't consider some problems. And one serious problem is not only the cosmic radiation, is not only the microgravity, is not only the vacuum, it's the substances, chemical substances, which produce strong oxidation. And these substances are created because of radiation, are created because of micrometeorites hitting planetary surfaces in general. So this is the problem we want to solve, and especially what we will have as a problem with lunar dust, which is a very serious problem because it's biotoxic, and it's abrasive, and it has many other chemical characteristics and physical characteristics that affect astronauts seriously, badly, and they affect also our instruments. All your instruments and materials that we are producing here, they will be affected if you want to take them to the moon. So what we do is actually we make a range of sensors. These are microfluidic systems actually that monitor cosmic oxidants in this space environment, any space environment, but also on Earth, as I will say later, some applications. Then we produce ultra-high fidelity space environment simulants. This is very important. This is actually developed at ESTEC while I was there. And what it is actually, we produce actual simulants one-to-one in every aspect with lunar dust, and not only the dust, but also the space environment on the surface where all operations will take place. So this system is here in Greece now, and we can test all your instruments for thermal applications, for problems, for electrical ones, for biotoxicity, any kind of application. And those two together, if we scale them up, we go to ISRU, especially of oxygen, because from lunar dust you can extract oxygen very easily, very cheaply, no energy at all. Actually, it's exothermic, it produces energy, the whole thing. So these are our main topics, plus additional ideas that we have, all of them, yes, from supported by ESA. So this is what we want to achieve here, stay on the moon and every surface very long. Because if we don't do this, then missions will fail very quickly. We want to enhance the time to enable all the missions and staying on the moon for longer period. So the commercial environment it does not exist at the moment. These are totally new things. If you have instruments to measure these properties, these instruments are very big, difficult. We speak about micro-instruments. And finally, we have some collaborators right now, ESA, of course, through all the projects. Solstice Mining, we think about, from Norway, we think about common products, actually on simulants. X Labs will take us to the asteroid Apophis. This is all of them under NDAs and MOUs. And NanoQ for enhancing our materials to build better and smaller devices. Okay. Thank you very much. This was.
Thank you very much. I think your case was the only one that had the smart move of pitching the sales to the audience. You said you can buy from us, so extra points for that. In any case, we are more than half done, so don't worry. 9 extra teams. So we will not have any delays. So thank you very much for keeping it short. 9 more teams means half an hour about. So yeah, we will be on time. Don't worry. So next team is Sky, also one of the youngest teams, and it will be the last one related to the upstream sector that we have had in the first section, and then we will move on with downstream startups. Thank you.
Hi everyone. My name is Ronaldo. I'm an engineer at Sky. Sky is a newborn company. We're just 4 months old or 5 months old, something like that. In a few words, what we do, we're basically designing immersive 360 imaging technologies for space. Excuse me for my notes, but it's... So the problem we're basically trying to solve is that when we launch something into space or when we send something to a planet, we don't have visibility to that system, right? So think like this. We launch a spacecraft, we launch a satellite, and it's now in orbit. How do we see that the deployables are actually deployed? We are relying on telemetry, right? But that telemetry doesn't tell us the whole truth. Also, we send rovers to Mars, we send rovers to the Moon, we send rovers to other planets. Rovers rely on mainly on visual data to navigate. They require visual data. So at Sky, we are introducing 360 imaging for space, where we are trying to ruggedize 360 imaging systems, which basically give us a full view, a full spherical view, and we can turn our head, for example, and see around us and see stones and see and provide in that way the navigation that we need. We are targeting a low mass design, under 400 grams, which mass it's pretty important, as we all know, for space, because it's very costly. It's specifically designed for space, which means it's ruggedized at 100%. We are trying to solve all thermal issues, all radiation issues that we have. And also, we are trying to keep it, how can I say it, interactive, let's say. I have a video here which shows one of the earliest experiments of Sky. It's the exocam. It's a basketball-sized unit that attaches on a rocket. The rocket flies and simulates in that way the lander. Then it ejects our payload. Our payload, it falls down and it still records the spacecraft landing. So as you can see here, the payload will detach and start to fall. It hits the ground. It's safe, to be afraid. And as we can see, we have a full 360 view of the lander falling down. This experiment was performed under NASA's coordination for the surface lunar plume investigation experiments. This is a recent one, a recent experiment which we attached one of our cameras into a rover, into the Exolith laboratory in California, I think. And as you can see, with just a single unit, we can see around, we can select targets, we can facilitate in that way the navigation of that rover. Basically, we're targeting space, mainly Moon. But we're open to terrestrial applications as well. I mean, we are offering a ruggedized system, so it can be used on radiation plants, on harsh environments in general. And of course, we are trying to open up, and so we are giving you the chance to lend one of our systems and use it on your own systems and give us feedback on that. We're open on collaboration. That's all. Thank you.
Thank you very much. I hope we see your camera in space mobility's robots in the future in a simulation, physical simulation laboratory from Stellar Discoveries. Let's go. So we move on with the downstream sector and our Earth observation startups. We have a representative from ALONGROUTE, which is the first one.
So, good morning. I am Pavlos. I am the AI engineer behind ALONGROUTE Data. And in ALONGROUTE Data, our vision is to make maritime weather intelligence to be more trusted and have more applications in the future. So, to begin with, can you guess what ocean forecasts have in common with, for example, guessing the biological sex of the baby? Well, both of them fail about half of the time. Still today, 50% of 7-day forecasts are unable to predict the ocean conditions correctly. And this because numerical forecast models produce systematic errors, and ocean observations are not enough to minimize the problem. So, when forecasts fail, historical data fail as well. And can you imagine how many maritime operations depend on the accuracy of this data? Well, basically all of them. But voyage optimization is losing skill, credibility, and the opportunity to excel at shipping decarbonization. Operators and charterers are losing time and money with endless cycles of claim assessments. Offshore operations are getting more and more less productive, and each compliance misses critical information for more defensible products. Bottom line is that failing marine weather data is causing the industry to bleed money, efficiency, safety, and of course, all this happening while polluting our planet with unnecessary global emissions. So, we address this problem at its very core, and despite our competitors, we use a different approach. So firstly, we try to understand what actually happens at sea. So we reconstruct past conditions using ocean observations and industry baseline, and then we apply our AI models to predict future conditions. So this brings more accurate forecasts for the future, and in intense sea states, later within the forecast horizon, and in high resolutions. So, at the same time, we are building accurate historical database. So within the same platform, we are offering trusted historical data and reliable forecasts on a global scale. So the added value is very specific. Improvement in marine data, marine weather data, can bring additional revenue, savings, and operational efficiency to the industry. And at the same time, as already mentioned, we contribute to the reduction of the unnecessary emissions coming from the maritime industry. Let's say the global accuracy combined with maritime focus and strong expertise from our team is what makes our clients trust us and give them greater value. We have gathered an amazing group of people covering all aspects from science, technology, business, and growth. And we're structuring also an advisory board with selected key profiles from the industry. In this way, we support our consistent traction, including revenue, pilots, collaborations, and grants, and we already have a signed term sheet on the table at the moment. So the opportunity is significant. We estimate that in the next 5 years we will have a B2B revenue between 7 to 14 million, and at this point we are raising 750k, where 400k is already secured, and the round cycle is closing in September. So we have the team, we have the knowledge, and we have the solution. Join us in our adventure for safer, greener, and more profitable maritime operations. Thank you very much.
Impressive, exactly as much time as you had told me. He knew it would be more than 4 minutes, but by a few seconds. Anyway, thank you very much. We move on now with AUTONOMA.
Okay, so hello everybody and good morning. I'm Ioannis Daramouskas. I'm co-founder and CEO of AUTONOMA. In AUTONOMA, we design and we create software solutions for unmanned vehicles. Solutions about autonomy, swarming, perception, under the umbrella of emission management software. And we can provide end-to-end solutions based on our customer needs that utilizes our softwares. So what is the challenge? As we can see, we have a mass adoption of drones, and drones are used across many applications, such as defense, civil, and emergency responses. As a result, massive amount of data are produced, and we have no insight at all about this information. And it is a fact that humans can't keep up. They can't process this information. The remedy to that is Icaros. Icaros is a video analytics software toolkit that takes raw drone footage and provides situational awareness. It provides reduced cognitive load and time saving in real time with great accuracy. Which are the capabilities of Icaros? Icaros can detect objects of interest. The objects can be tracked across a sequence of frames. We can geolocate the objects using satellite images. We can fuse the information from multiple drones, and we can support different kinds of sensors. Now, regarding our technical readiness level, we are in level 7, and we have get operational validation from the military exercise called GEONOVA that we participated in November. We have provided a product in the Hellenic National Defense General Staff, and we make an operational demo. And also we have made a pilot with the Greek electricity distribution network. Here you can see a short video of Icaros in action, that it can detect objects and geolocate them and track them in real time. Now, what makes us unique? Why we're attractive? First of all, we don't need any additional sensor, any additional camera in order to perform the geolocation. We are vehicle agnostic. We can play in, we can adapt in any vehicle. We are scalable because we can be used in a multi-UAV scenario. We have great accuracy, and our inference time is significantly low. And of course, we can provide unified situational awareness. Now, regarding of what we're looking for, we look for collaborations with UAV manufacturers, with drone as a service providers, and with government bodies. such as police departments, fire departments, municipalities, prefectures, and regional units, and of course, military units. Thank you very much.
Congrats, you were the fastest one. I like it. Next, we have Pollux Tech. Do we have a representative from a company? No? So Pollux Tech is building a new device that will be communicating through SAT-link with the corresponding authorities in case we have a man overboard. And I'm saying that because I wanted to follow up with a joke, but maybe the Pollux Tech team got lost in the ship. But anyway, I'm sorry for this. So I hope they are having a pilot of some sort like this. So we can move on with the next team then. Oh, okay. And we have Moistex.
Thank you. Good morning. So imagine a world that we know earlier and better about the floods, about the wildfires, that for every field in this world, we know how many irrigations we have, how much water we need, and Moistex having this role to empower all these organizations that has this vision. So we have a scientific background. We love science, open source software. We provide some software capabilities open source, and we embrace the future. We are early adopters of the new NICER mission. So the problem, as I described, is that right now we don't have accurate soil moisture data. And what we do is that we use SAR data, we use L-band and P-band data from the NICER, from the biomass missions. These missions will continue. We will have Roselle from ESA. So I think the timing is right. And our mission is to provide affordable, high resolution, and localized soil moisture information. We use SAR data, we use multispectral data, but we also use thermal data. We combine all these earth observation data with ground soil moisture observations. We have developed a data-driven approach, and we are able to provide soil moisture intelligence to solve these real-world problems that I described. So we can, why this soil moisture from space is important? Because we can know the irrigations retrospectively. We can schedule, we can optimize our irrigation schedule. We know better the duration and the intensity of drought events using historical data from 2015 till now. We know what to do to be better regarding the climate resiliency. We can manage our water more efficiently, and we contribute with soil moisture. We can have better parametric insurance. So what we offer is at 20 meters from 2015 till now, let's say every couple of days due to cloud coverage, we can provide you soil moisture at the top 5 centimeters, but using this long wavelength SAR data, we can also go a bit deeper, closer to the root zone. We had a contract with ISI we have identified the potential of X-band SAR data. We use thermal data. We work with Auroratech and SATFU, and we are also developing a focused GNSS reflectometry payload for UAV to provide high resolution soil moisture. We have API users, and we invite you to subscribe, to go to a link, and to try our data to see if we can help the world. Thank you.
Thank you very much. We did find the Pollux Tech team. They weren't lost in the sea. Were they? They were? Okay.
Hi everyone, thank you Orfeas for the invite. First of all, excellent organization. This is Giorgos Exarchou from Pollux Tech, Polydevkis Technologies in Greek. This is our pitch. Our motto is we expand and we transform the maritime safety domain from vessel-centric to human-centric. Why we say this? Because every year 1.9 million seafarers and 32 million cruise passengers are on board at sea without any personal individual safety on them whatsoever. The only mandatory technology for the maritime safety is the EPIRB, the one on the left. The one on the left is mandatory, standardized, defined by the IMO, but it's vessel-oriented. The other approach is the PLP, the personal locator beacon. You might be familiar with some of them, because it's a fragmented market with non-mandatory, non-standardized, undefined, but human-centric solutions. So what we're trying to do is to expand the logic of the mandatory device into a wearable. Both of them use the COSPAS-RSAT constellation, which doesn't allow for wearable format device because it's at 20,000 kilometers, whereas our solution uses low Earth orbit capabilities. Humanitarian, okay, but not really the point. The thing is that there is an economic challenge behind maritime safety with hefty personal and indemnity costs every year, energy inefficient search and rescue operations, ESG-related costs for the companies that are in the stock exchange. Our solution, ASOS, Autonomous System of Overboard Safety, you understand the point. It's a beacon, a wearable beacon, waterproof, using a constellation of low Earth orbit. We have already contracted Iridium, which is the only one low Earth orbit constellation covering totality of the Earth, including the Arctic. The other one would be Inmarsat, and COSPAS-RSAT is the 406, the one being used by the EPIRB. We are a member of the European Space Agency Incubator, Iridium, Evidite, Propeller Club, and Bureau Veritas. Bureau Veritas, why? It is very important to know that the maritime segment is very regulation heavy. So what we do, we go to the IMO, we take Bureau Veritas and say, look, take the performance standard of the existing solution that is on every ship and do not use the 406 for the communications, use Iridium's GNSS infrastructure under IMO. So we will go to the IMO and say, guys, we have a very big chance of going into the safety of life at sea convention and becoming mandatory for every human on board due to the fact that we are using existing IMO resolutions. We are proud of our ecosystem that has converged around ASOS. I announced today that Prisma Electronics is the partner that will do the prototyping. We signed yesterday. Bureau Veritas, global interest. Their interest. We're working with the headquarters of Bureau Veritas, not the Piraeus segment. Iridium, we're waiting the first kind of chipsets around August, and we're going to have our first trials within the Q1 of 2027. So that's a record time of both the pitch and the development of a solution. Our market is a 1.7 billion market per year, and yeah, thank you. I'm way below 4 minutes, and thank you very much. Any questions?
Congrats to Pollux Tech. Also, congrats to the cameraman for his quick reflexes. Because we had the more interactive presentation. Okay, stop moving. Sorry for this. Okay, so thank you very much. we can move on with Mantio. And yeah, as promised, we are almost done, people. Thank you very much for your patience, for staying, all of us, all of you with us. Go.
Great. Let me also put my timer because time is money and we want both, right? I'm Charalambos Gavilidis and I will present to you Mantio, our platform for Earth intelligence in the AI era. Great. So all of us in this room know that we have plenty of data and data is being produced, but the problem is how we get from this data to the insight, right? So we have business questions and we need to get some insights there. And this is because of data fragmentation. We have data all over the place. We have geo-distributed data. Data is in different formats. And also there is a technical barrier, right? So we need expertise about the data and the tools to process that data and get to that insights. So what happens is that Earth intelligence stays locked into the data and we cannot extract it. This is a problem. So let me be more concrete. I brought to you an example of how data processing works nowadays. So everything starts with a business question, and then we have the experts in the middle that actually have to find the right data, use the right tools, learn about them, do some analysis, employ some machine learning, and in the end create a report that consists of maps and maybe graphs that we can give back to the business users so that they can answer their questions and do their decisions. This has many problems, but actually it doesn't scale both across data and across teams. This is a problem. So we try to reinvent that by proposing the Mantio AI platform. As you can see here, we took the experts out of this circle and we replaced them with our Mantio platform. We don't actually replace the experts, right? So we want that the expert focus on what they do best and where they add value, which is curating the data, the models, and the knowledge, right? This is the context of the business today. Experts should be there. And business users should be able to just ask questions and then get insights. This is what we enable with Mantio. And this brings many advantages, but I want to focus on the last one, which is the capability democratization. So we enable non-experts to actually get insights on the data, which actually needed a very complex processing. This is how the platform looks today. As I told you, this is conversational data analytics, so users ask questions in natural language on data that they have imported from multiple sources, and they get their answers in forms of plots or maps, as you can see there. So here we have a flood risk analysis example. Great. So we actually graduated from the ESA incubator last month, and during that time we have moved from MVP to, let's say, operational platform. The platform is live and you can use it. And during that time we also validated that there is this need out there. So people actually want no-code interfaces to analyze geospatial and Earth observation data. We validated the platform across different use cases through pilot and private beta programs. And we saw that actually people save 1/3 of their time when using our platform. And we have also validated that you can use this platform across different use cases from, let's say, natural hazard detection to supply chain data analytics. This is our vision. So we want to enhance our platform to also be able to help you with finding new data that you don't possess and can help you with analysis. And then we want to actually go to the agents that works while you sleep, as we say, right? And this has many steps from becoming our agent, becoming a senior analyst and an AI expert by enhancing them with machine learning and AI capabilities. Great. As we say in Greek, words are poverty. I invite you to try our platform. Please scan the QR code and register with this promo code. Thank you very much.
Did you keep the promo code? Do I change it? Yeah, sure. It's easy. Wait, no? Change. Okay. Okay. So, we move on with GEONOVA.
With the arrows? Okay. Hello, I'm George from GEONOVA, a company that lies in the intersection between intelligence and Earth observation. I will start with a story. in order to make what we do more understandable. I mean, the story is about the downstream applications. And more or less, I'm talking about almost all the downstream applications. I mean, we have worked in a lot of them. The story is going like that. One guy said, okay. One guy say, oh, I got some measurements that I can use for to provide a satellite service. What a happy day. EO scientists telling me, yes, okay, probably you need the Sentinel-5 with the band 3 and the band 9 and the HH band of SAR. After one youngster data science said, okay, yeah, we're going to train an algorithm. It's the XYZ algorithm, or maybe it's the ZYX algorithm. And everything is fine. After he said, okay, I had some problems. I did some cleaning. Now we have only 15 data points. At the point around 3 months or 4 months, the guy say, okay, guys, we have anything that works. We have any algorithm that converge. At this point, the EO scientist will say, I found another band in satellite 0 and correlate 0% with our target. We have to add it on the model for sure. This is very critical. After the youngster will say, we need more data. After we can say we need more GPUs because my problem was that we haven't a very big model yet. And okay, after roughly 6 months to 1 year, okay, okay, my idea was wrong, okay, this is not working. This is more or less a repetitive pattern in almost all the downstream applications that exist. There is any hope? Yeah, yes, there is. Yeah. Somehow it's us. Okay, yeah, we know that the EO field has a lot of heterogeneous data. The 80% of the time is wasted in data preprocessing and data wrangling. One very important thing that we have to understand is that every project costs 50K to $500,000, even if it not works, just to test it, to say, okay, I'm going to test it in a little bit larger scale. What we do is that we use generative AI, we blend multiple missions, we blend in situ data, we blend information around every data source, and we provide a specific embedding. So we inject all the information to a ready-to-use data that after you can take this data and use it to whatever is your downstream task. I mean, we have seen, that the deployment is much faster, the cost is much less, but what is more important is that you need less data. And this is something that is totally out of the scene. I mean, you need less data to build and to train a machine learning model to do what you want if you use embeddings than to use the raw satellite in situ or whatever. Here is our roadmap. We release a beta version of the platform that you can download embeddings from our simplest models, the one with Sentinel-2 and in situ, and the one with Nmap data. We have promised that to Orfeas and Alex that we're going to do it before the Greek Space Tech Forum, and we released it yesterday.
Actually, this video had sound.
Yeah.
You could hear yesterday's.
Indeed, Eleftheria was.
So there's documentation and it's time.
Yeah. Our next stop is at the end of August. Okay, to have finalized the beta version to identify the problems and work properly, and to upload better models that we have. Our next stop is on September, that we're going to do a call for collaborations for every company that wants to work together and to tailor and to handcraft a generative AI model with its needs and for her purposes. And at October, November, we're planning to release our AutoML feature. That means that, okay, you're going to upload your data and the platform going to train the model for you, and you're going to download the model. I mean, okay, probably it's bad for master students, but okay, it's good to have something that works. We are GEONOVA. Thanks a lot. Let's stay connected. And yeah. That's all.
So in the very improbable scenario that this doesn't work, you can pivot to comics industries. You have my approval. I will subscribe. I will be a patron or whatever. Okay, just let us know. So we move on with the next team, which is Scale Up, introducing Spheroid.
Hello, I'm Apostolos from Scale Up. I will present you Spheroid. Generic IT monitoring systems focus on server uptime. However, Spheroid is different because we focus on geospatial data quality. Spheroid is built in order to improve the stability and the accuracy of Earth observation and geospatial applications. Earth observation system fail silently. In existing tools in the market, focus on like a Monte Carlo, focus, for example, for standard databases health, or other tools in the market like DataWatch or New Relic, focus on IT components, but they do not understand the satellite data. This is because they do not speak the language of a geospatial ecosystem. So major quality failures and issues still stay hidden. We have this problem during the development of services and applications for ESA Destination Earth ecosystem. So despite our system looked healthy and all dashboards were green, the final results were incorrect. So, and the worst scenario was that the worst scenario was that we found out the problem directly from the end users. The end users reported to us the problem, so we need something to fix that. Okay, how the system works? It is totally on-premise. We set up the Spheroid to the customer's infrastructure. No data leaves from the outside of the customer's environment. We detect silent failures and general issues before go to the end user. We have built an agentic AI agent that runs root cause analysis in order to help engineers to find out the problems quickly. We provide help for the system stability, and finally we provide reports and metrics with quality evidence. Up until now, we have some early revenues from ESA Destination Earth service providers. We have also some discussions on September with Alice Group in order to find out collaborations and synergies for the quality framework of Destination Earth. Why now? Because if you remember for the past, the web applications became too critical and production-ready infrastructure. They needed observability tools, so we believe that Earth observation sector also follow this path. Our vision is to be the observability layer for Earth observation systems, like a Monte Carlo for the domain of Earth observation. So currently, we are seeking investment in order to grow our sales team and the business development department. Thank you.
Thank you very much, Scale Up team. And last but not least, you had the chance to present. You didn't.
She's in the panel today.
Did she make the comic at least or not? No.
So thank you. I hate it when I'm waiting for my turn to present. Anyway, so hello everyone. This is Eva Papadogiannaki. I'm one of the two co-founders of Telescope. So let's see directly the problem, the challenge that space operators currently face. So first of all, there is the encryption blind spot. What this means? What? Oh, sorry. Malicious actors currently are hiding inside the encrypted and authorized network communications. This makes all the many of the legacy security tools get blind. Also, there is the privacy deadlock. In order to bypass this thing, someone could say that inspecting the traffic would be easy after decrypting it. Of course, this is a violation for the privacy. So it also raises legal risks. Also, it's the compliance and financial work. Specifically, the concurrent NIS2 and EU Space Act require strict risk management. So non-compliance can bring monetary penalties, and most importantly, direct personal liability for executives. And finally, there's the operational costs. It is known that cyber incident can cost millions of euro in recovery. So it can also trigger several cascading failures and disruptions in global navigation systems, telcos, etc. So this is why we propose Telescope. Telescope proactively provides a proactive threat intelligence, so we're not waiting for the malicious actor to hit. We are constantly interrogating target infrastructure in order to make the servers reveal if they have malicious or weird behavior and activity. We also offer explainable AI, so every alert comes with a reasoning log and a confidence score as well, so the security analyst is able to be certain about their actions and also be ready for an NIS2 audit. Finally, we don't do any decryption. We analyze parameters and metadata. So in this way, we are able to preserve compliance and privacy. Something else that's not added here, the solution is completely made in the EU. So we promote data and data autonomy in threat intelligence. So no need to get into details about how we deliver Telescope. We have the cloud-based software as a service, the on-prem deployment for sensitive environments, and the threat intelligence feeds. So at this point, since we are here, you understand that we are one of the ESA BIC GR startups. We recently got notified that one proposal that we contributed in were selected and granted from the digital SME support actions. Also, we operate more than 40 high-performance scanning nodes in our privately owned cluster. And at this point, we have more than 65 early adopters for our cloud-based service, and also our threat intelligence feed is validated from an MSSP. At this point, we are looking for pilot partnerships and also strategic collaborations. And to conclude, this is our dream team. The two co-founders, me and Professor Ioannis right there, we have a combined experience of more than 40 years together in cybersecurity. Mr. Labrou is our AI lead, and Mr. Michalodimitrakis, our senior DevOps. So that's all. You can scan here this QR code and register to use our system. So yeah, thank you.
So that was it. Thank you very much, everyone, for your patience and your presentations. There is a free Wi-Fi available for you to connect. Please scan this code, select the free of your favorite teams with whatever criteria at this point, okay? And please, it's mandatory, provide one sentence of a suggestion, a note, something about any of the teams you want, okay? Something you didn't like that much, something that could be improved, maybe something that you liked a lot, whatever. We will give you 5 minutes, okay? If you want to provide...
To have the logo next to the name, you know?
I'm sorry?
It would be helpful to have the logo at least next to the name of the company.
We accept the feedback. We accept the feedback. If you don't remember one of the teams or what they do, you can ask freely, it's okay. So let's have 5 minutes on that. In the meantime, I would like to thank a lot all the supporters that were not immediately observed during the presentations, the technicians, as we said, thank you very much, the photographer, the janitors, and so on and so forth. So, 4 more minutes, and then Alex will be happy to announce the winner.
We're getting some votes, so everything works.
Okay, okay. All systems green.
Who needs World Cup when we have this the live score?
If you don't remember the name of the team, you can raise your hand and we can come and tell you. Okay. Alex, how many votes?
12. 12 votes.
Θα έχουμε αυτοδυναμία ή θα πρέπει να γίνει συνασπισμός.
Ναι, το πας με νούμερα. Δεν κοιτάω αυτά, κοιτάω μόνο αυτά.
Τα νούμερα.
Τα νούμερα είναι online. Αυτά ναι, δεν είναι, αυτό πάει πολύ πιο κάτω. Το πας με χρώμα.
Who needs more time? Just raise your hand. It's okay. Yes, thank you. We will wait. Yes, not to us.
To specific team.
To us, to me during the sync on Friday. Yeah. I still see just a couple of people writing.
The three first teams, they won any t-shirt or any...
The first team wins a voucher of 1,000 euros for trips in Bahamas. T-shirt, you can buy as many as you want at our e-shop, which is not open yet. So, is anyone still needing some extra time, or we are done? Are you just doom scrolling, or indeed feeling it? Okay. We close the voting. Yeah. I didn't think of having a sound effect. Next year. No.
Me? No, come on. Okay, everyone. Out of 44 votes, thank you very much for voting. We have the winning team, which is the Space.
Here you can get the invisible check. So thank you very much. We tried to group you during the presentations with other teams we think you may have some kind of synergy. So we hope you follow up in the next discussions outside. And yeah, thank you very much once again.